We're going to find rational roots. First of all, the word rational means it can be written as a ratio of two integers. And the word root means it is a solution, a zero or an x-intercept. The value of x that makes the y value equal to 0. So what are the rational roots of 2x to the third minus x squared plus 2x plus 5 equals 0? So we're finding the rational values of x that make the y value equal to 0. Well, the only possible rational roots have the form of taking the factors of the constant term over the factors of the leading coefficient. So factors of the constant term, factors of 5, could be positive or negative 1 or positive or negative 5. And the factors of the leading coefficient, factors of 2, could be positive or negative 1 or positive or negative 2. So the only possible rational roots, taking factors of the constant term over factors of the leading coefficient, would be taking positive or negative 1 over positive or negative 1, positive or negative 5 over positive or negative 1, positive negative 1 over positive negative 2, and positive negative 5 over positive negative 2. So factors of the constant term over factors of the leading coefficient. So if you do that, taking 1 over 1, that would be positive negative 1. Then taking 5 over 1, that would be positive negative 5. Taking 1 over 2, that would be positive negative 1/2. And taking 5 over 2, that would be positive negative 5/2. So if we look at the chart, by putting those values in for x, this is the chart that is created. We're looking for what value of x makes the y value equal to 0. So the only value of x that makes the y value equal to 0 is negative 1. So the only rational root of that 2x to the third minus x squared plus 2x plus 5 equals 0 would be negative 1. What are the rational roots of 3x to the third plus 7x squared plus 6x minus 8 equals 0? So what are the rational values of x that make the y value equal to 0? Well, the only possible rational roots are taking factors of the constant term over factors of the leading coefficient. So factors of the constant term would be factors of negative 8, and factors of the leading coefficient would be factors of 3. So factors of negative 8 could be positive negative 1, positive negative 2, positive negative 4, and positive negative 8. And then factors of the leading coefficient, factors of 3, could be positive negative 1 and positive negative 3. So to find the possible rational roots, that doesn't mean these are the rational roots, only possibilities. The possible rational roots are found by taking those constant factors, each one of those constant factors, and putting those over each one of the leading coefficient factors. So if you do that, if you take each one of those constant factors, putting those over each one of the leading coefficient factors, you get this list. Positive negative 1, positive negative 2, positive negative 4, positive negative 8, positive negative 1/3, positive negative 2/3, positive negative 4/3, and positive negative 8/3. That is a very long list of possible rational roots. So imagine taking each one of those, substituting in for x, and deciding which one of those makes the y value equal to 0. That's going to take a lot of work. Now, if you take each one of those and put those in for x, the only one that makes the y value equal to 0 would be that 2/3. Imagine taking each one of those values for x, substituting those in, seeing which one makes that a true statement, which one makes y equal to 0, and only getting one to work. That's a lot of work. There is an easier way, which you'll see in a little bit, but for here, the rational root, the only rational root, is 2/3. What are the rational roots of 15x to the third minus 32x squared plus 3x plus 2 equals 0? So what are the rational values of x that make the y value equal to 0? Well, we have a third degree polynomial. Once you find one root, use synthetic division to factor the polynomial. Then continue finding roots and dividing until you have a second degree polynomial, in other words, a quadratic. Use the quadratic formula or factoring to find the remaining roots. So the very first thing we need to do is find the possible rational roots. And to do that, you take factors of the constant term over factors of the leading coefficient. So factors of the constant term, factors of 2 would be positive negative 1 and positive negative 2. And then factors of the leading coefficient, factors of 15, would be positive negative 1, positive negative 3, positive negative 5, and positive negative 15. So the possible rational roots are taking each one of those constant factors and putting those over each one of those leading coefficient factors. As you can imagine, you're going to end up with quite a list. So the list of possible rational roots would be the positive or negative of each one of these. Positive or negative of 1, 2, 1/3, 1/5, 1/15, 2/3, 2/5, and 2/15. So that is quite a list. We need to get one of those to work. So we need to substitute those in until a root is found. That gives us something to work with to find the other rational roots. So start with something easy. You want to avoid those fractions unless you absolutely have to use those. Start with the 1s and the 2s. So I'm going to start with positive 1. If I manually substitute 1 in for x, I'm going to end up with 15 minus 32 plus 3 plus 2. That is not equal to 0. So 1 is not a root. Move on to something else, either negative 1 or 2 or negative 2. I'm going to try 2. So if x equals 2, when you substitute that in, you end up with 120 minus 128 plus 6 plus 2. That does equal 0. So 2 is a root. Now remember back to synthetic division and synthetic substitution. When we were dividing by x minus 2, that's the same as substituting 2 in for x as far as the remainder goes. So if you think of synthetic substitution, synthetic division, when 2 was a root, that meant x minus 2 was a factor. So since 2 is a root, x minus 2 is a factor, we're going to divide this polynomial by x minus 2, and that will give us another factor. So if you divide that polynomial by x minus 2, we're going to use synthetic division. Now, synthetic division, list the coefficients, 15, negative 32, 3, and 2. And then we're dividing by x minus 2, so that means a positive 2 goes in the box. Now proceed with synthetic division, bring down that 15, and then go back to the box. Multiply 2 by 15, that is 30. And then add negative 32 and 30, that is negative 2. Go back to the box, multiply 2 by negative 2, that is negative 4. Then add 3 and negative 4, that is negative 1. Back to the box and multiply 2 by negative 1, that is negative 2. Then when you add, you get 0. So the remainder is 0. That means definitely you are dividing by a factor, but we ended up with another factor, 15x squared minus 2x minus 1. So these are the coefficients of that other factor. 15x squared minus 2x minus 1 is another factor, along with the factor we already have of x minus 2. So if we can factor this 15x squared minus 2x minus 1, or possibly use the quadratic formula, hopefully that will end up giving us more solutions, more roots. So this 15x squared minus 2x minus 1, I'm going to try factoring that, and that does factor into 5x plus 1 times 3x minus 1. So now we have three factors, three linear factors. X minus 2, 5x plus 1, 3x minus 1. So again, that 5x plus 1 times 3x minus 1, you would get that by factoring this 15x squared minus 2x minus 1, factoring by grouping. It's going to take a little more time, but you do get two more linear factors. Now, these three are all equal to 0. So if we set each of these three equal to 0, set x minus 2 equal to 0, you're going to end up with x equals 2. And then set 5x plus 1 equal to 0, solve that for x, you end up with x equals negative 1/5. And finally, set 3x minus 1 equal to 0, and you end up with x equals 1/3. So those are the three rational roots. And you can see that on the graph that x does equal 2, negative 1/5, and 1/3, finally. What are the rational roots of 2x to the third plus x squared minus 7x minus 6 equals 0? Well, the first thing you need to do is find the possible rational roots. And those are found by taking the factors of the constant term over the factors of the leading coefficient. So factors of the constant term, factors of negative 6 would be positive negative 1, positive negative 2, positive negative 3, and positive negative 6. And then factors of the leading coefficient would be positive negative 1, positive negative 2. Those are factors of 2. So the possible rational roots are found by taking each one of those constant factors and putting those over each one of those leading coefficient factors. And when you do that, you're going to end up with quite a list. So you end up with the positive or negative of 1, 2, 3, 6, 1/2, 3/2. Taking each one of the constant factors, putting those over each one of the leading coefficient factors. Now you want to get one of those to hit. So you want to substitute those in until a root is found. And you don't want to start with the fractions. That's too much work. You want to start with something easy like 1 or negative 1, 2 or negative 2. So I'm going to start with 1. If I substitute 1 in for x, just manual substitution, we end up with 2 plus 1 minus 7 minus 6. That is not equal to 0. So you need to move on to something else, maybe negative 1 or positive 2. So if I try positive 2, if you substitute 2 in for x, we end up with 16 plus 4 minus 14 minus 6. That does equal 0. So when you substitute 2 in for x, both sides equal 0. That means 2 is a root. And that gives us something to work with. Since 2 is a root, that means x minus 2 is a factor. So I'm going to take that polynomial and divide that by x minus 2 and get another factor. I'm going to use synthetic division. So synthetic division, dividing 2x to the third plus x squared minus 7x minus 6 by this x minus 2, by this factor, that's going to give me another factor. So with synthetic division, since x minus 2 is a factor, I'm putting a positive 2 in the box. If you put a positive 2 in the box, bring down that first coefficient, bring the 2 down, then go back to the box, multiply 2 by 2, that is 4. Then add 1 and 4, that is 5. Back to the box, multiply 2 by 5, that is 10. Then add negative 7 and 10, that is 3. Back to the box, multiply 2 by 3, that's 6. And then add negative 6 and 6. Of course, you're going to get 0 because you're dividing by one of its factors. That creates another factor. These are the coefficients of that other factor. 3 is the constant term, 5 is the coefficient on the x, and 2 is the coefficient on the x squared. So now we have two factors, x minus 2 and 2x squared plus 5x plus 3. But that 2x squared plus 5x plus 3 might be able to factor into two other factors. So if you factor that by grouping, that 2x squared plus 5x plus 3, we're going to split that 5x into two terms. Their coefficients multiply to get what 2 times 3 is, so multiply to get 6, and add to get that middle coefficient of 5. So two numbers that multiply to get 6 and add to get 5 would be 2 and 3. So I'm splitting that 5x into 2x and 3x. Then factor by grouping, group those first two terms together, the 2x squared and the 2x, and factor out a 2x. So if you take a 2x out of those first two terms, you end up with x plus 1 in parentheses. Then group the last two terms together, the 3x and the 3, and factor out a common factor there, which would be 3. If you factor 3 out, again, you end up with x plus 1 in parentheses. So x plus 1 is a common factor to those two terms. If I take that x plus 1 out, just like erasing it, I'm going to be left with 2x plus 3. So there you have three factors, three linear factors. Those three multiply together to equal zeros because we took that 2x to the third plus x squared minus 7x minus 6 and factored it into x minus 2 times x plus 1 times 2x plus 3. So that's equal to 0. So to find the values of x, set each one of those equal to 0. Set x minus 2 equal to 0, x plus 1 equal to 0, and 2x plus 3 equal to 0. And then solve each one of those for x. When you do, you end up with 2, with negative 1, and with negative 3 halves. So those are the rational roots. The rational roots are 2, negative 1, and negative 3 halves, and you can see that on the graph. It hits the x-axis at 2, and negative 1, and also negative 3 halves. What are the rational roots of x to the third plus 3x squared minus 6x minus 8 equals 0? Well, the first thing we need to do is find the possible rational roots, and those are found by taking the factors of the constant term over the factors of the leading coefficient. So factors of the constant term would be factors of negative 8, positive negative 1, positive negative 2, positive negative 4, and positive negative 8. Leading coefficient factors, those are easy because it's just positive negative 1. And that's nice because the factors of the constant term will be the possible rational roots because you're taking each one of those constant factors and putting those over each one of the leading coefficient factors. Well, if you're putting each one of those over 1, it's just going to be that list again. So the possible rational roots would be that list of constant factors because you're putting each one of those over 1. So the possible rational roots are positive negative 1, positive negative 2, positive negative 4, and positive negative 8. Now we need to start substituting those in until we get one to work, one to hit. That gives us something to work with to get more rational roots. You want to start with something easy. You don't want to start with 8 or negative 8. Start with 1 or negative 1. So I'm going to substitute 1 in for x. So if I substitute 1 in for x, I end up with 1 plus 3 minus 6 minus 8. That is not equal to 0. So 1 does not work. You need to pick something else, maybe negative 1 or 2 or negative 2. So let's try 2. If you substitute 2 in for x, you end up with 8 plus 12 minus 8. That does work. That is equal to 0. So since 2 is a root, that means x minus 2 is a factor. And since x minus 2 is a factor, then I can divide this polynomial by that x minus 2 and get another factor. So I'm going to do that. I'm going to use synthetic division, list the coefficients of 1, 3, negative 6, negative 8. And then since I'm dividing by x minus 2, a positive 2 goes in the box. Now proceed with synthetic division. Bring down that first coefficient. So bring down the 1, back to the box, multiply 2 by 1, that is 2. And then add 3 and 2, that is 5. Go back to the box, multiply 2 by 5, that is 10. And then add negative 6 and 10, that is 4. Go back to the box, multiply 2 by 4, that is 8. And then add negative 8 and 8, of course you're going to get 0. So those are the coefficients of another factor. 4 is the constant term, 5 is the coefficient of x, and 1 is the coefficient on the x squared. So that is another factor along with the x minus 2 that we got earlier. So those are two factors, x minus 2 times x squared plus 5x plus 4. Now that x squared plus 5x plus 4, that may factor into two binomials. So we'll try that. To factor that into two binomials, the first terms would be x. The second terms multiply to get 4 and add to get 5. So those second terms would be 4 and 1. So now you have those three linear factors. We factored this into three linear factors that's equal to 0. So these three linear factors are equal to 0. That means you can set each one equal to 0 and then solve for x. So if you set x minus 2 equal to 0, then x equals 2. If you set x plus 4 equal to 0, then x equals negative 4. And if you set x plus 1 equal to 0, then x equals negative 1. So those are the rational roots. Remember, we had these possible rational roots. Obviously, they weren't all the rational roots. These are the only three rational roots. 2, negative 4, negative 1. Remember, the degree of your polynomial will tell you how many roots you will get.